Lesson 42, solubility rules. Hopefully you guys can see this. If you can't, please yell out because I want you guys to be able to see the PowerPoint in a moment. But what we're going to do is we will learn how to tell if an ionic compound is soluble. So, I realize now that there is a little bit of gaps here because what I really should have done very first thing in this lesson is go through the vocabulary. So I'm going to have to do that on the fly, but that's something that we can work on. Let's talk about what we did last lesson. So the very last lesson, which was last Friday, what I did with you guys is we talked about precipitation. Now this was just a little, this was almost like a little lesson at the very end of the week. It wasn't really, it was to try and get you warmed up for today's lesson. So what we did was we talked about what makes precipitation reactions work and what is a precipitation reaction. So precipitation is the formation of a solid from a solution. You add a liquid and you make a solid. Now I didn't tell you why the solid got made, I just told you the solid got made. And we said that here is an example. What we did is we took this example, we balanced it, we figured out what type of equation it was a double displacement, and we said, well, what is the precipitate? We said that lead iodide was the precipitate here. The reason that lead iodide was the precipitate was because it's a solid. Precipitate is the solid that comes out. So as you mix these two things, solid's going to sink to the bottom. We said, whoa, sorry about that. I've gone backwards. We said that what does a precipitate look like? In a solution, it can make a solution look cloudy, but if you leave it for, it may form a suspension. Now, suspension is not the same as dissolving something. A suspension is when the particles are big enough that even though they're evenly dispersed, you can't see through them, and so they do sink. Well, they don't have to sink, sorry. The suspension can just exist for a very, very long time. But usually a precipitate will sink to the bottom. It won't just stay floating around forever. And so you end up with some stuff at the bottom, which is called precipitate. We did two more. This was just a bit of a teaser for the next lesson. We said, look how this one, even though we're taking silver plus silver nitrate plus sodium chloride, we're taking potassium nitrate plus sodium chloride, we get silver chloride and potassium chloride. The silver chloride is a solid, but the potassium chloride is not. And so we said the top one is a precipitation reaction. You're making a solid, whereas the bottom one isn't. We were going to, I didn't say why. I didn't say how I knew that. I didn't say why is this one not, is definitely aqueous. I didn't say how I knew this. I just said, this is the facts. So today what I want to do is I want to give you guys the facts so you guys can look at anything and say, yeah, I reckon that's going to dissolve in water or probably not. So let's talk about, and then we finished up with solubility. AgCl is not soluble in water, which means it doesn't dissolve in water. When it is formed, it makes a solid. KCl is soluble in water, so no solid is made. So lesson 42 is today's lesson. We'll be able to learn how to tell if an ionic compound is soluble or not. I guess what I want to do first is I'd like to do a quick thing about vocab. Now I realize that normally what I would do is I'd write up this thing here. Because I don't have a pen, I'm just going to have to type it up. So you have to bear with me. Hopefully you guys can still see this even though it's not presenting. What I'm going to do is we're going to go through some of the vocab here. So the first one we're going to talk about is, I think what we should talk about first is just go back over soluble, insoluble. So we should go, yeah, let me see, where do we go first? Okay, let's go with dissolve first. We've just done dissolve because we just did that as, oopsie, double S. I know it's new, it's double S. We just did dissolve because it was part of the question today. So dissolve is going to be the first one. Is going to be a solid yeah, we'll go with the solid, becomes, a solid becomes evenly distributed amongst a liquid. Now, to be honest with you, 100%, that's not 100% true. You can dissolve a gas. So you can dissolve a gas into a liquid. I mean, like, otherwise, how would we ever get soft drink? Because that's what it is. So you could write a solid or gas. You can't really dissolve a liquid into a liquid because then you would just be mixing the liquids. But you could say instead a substance becomes evenly distributed. But yeah, you can dissolve gas. So it's actually not a, this is actually a pretty bad definition. I'm just giving you guys this definition just so that you don't, it's not too confusing. I don't want to give you like, oh man. But yeah. Okay, so soluble. Oopsies. Okay, soluble. What does
So are we
soluble?
supposed to write this down?
Yes, please.
Oh shit. Okay.
But it's all right. I'm adding to it as I go. So soluble is just going to be, let's keep it simple so that we don't have to do as much writing. Is soluble is something that can dissolve in water. Done. Insoluble, guess what? It's the opposite. Something that can't dissolve in water. Done. Just because we want to have the basics down. So when I say, oh, this substance is insoluble, that means it can't dissolve in water. So instead of dissolving in water, it forms a solid and sinks to the bottom of the test tube. That's why I said solid becomes evenly distributed amongst the liquid, because we're going to mostly be dealing with solids. We're not going to be dealing with dissolving gas into a liquid. But I know that if I put just, I know that if I left it as a solid, then maybe you might get confused. So the last thing is to talk about these three things: solvent, solute, and solution. Now these things are things that you should have learnt in year 7, but I will go through them now anyway, just in case. The solvent is the liquid doing dissolving. Okay, now usually 9 times out of 10 that is water. In chemistry, it's going to be water. But again, you can dissolve things in anything. You can dissolve things in alcohol. You can dissolve things in hexane. You can dissolve things in any number of solvents that, you know, a lot of solvents that you guys don't know exist yet. I had to spend a lot of time working with solvents when I did my master's of chemistry. So when I started off, I thought, oh, in science, I always thought, oh, there's just one solvent. There's just water, like that's it. Then when I got to the end of my master's point, I know so many different types of solvents: water, hexane, DMSO, ether. We'll go with chloromethane. Yeah, chloroform. That's a solvent. Remind me to tell you about my story about chloroform one day. God, that student was an idiot. All right, Wilson. Now, solute. Solute is the solid that is dissolved. And at the end, the solution is the dissolved solid mixture. It's the dissolved solid in liquid mixture. So that means at the very end, once you've got everything dissolved, you make a solution. So yeah, just because I'm giving you guys this vocab, just in case you need to know if it pops up in a question, you guys can figure it out what it means. All right, I'm gonna put this up like this, and I'm gonna change the slide in about, I don't know, say a minute. If you haven't copied this down already, you've got a minute to get it down. Again, some of you guys are doing some screenshot stuff, you can do that. But I'm going to, and copy it down later, but I'm going to change the slide in about 30 seconds. More like 45.
Yeah, I'm done.
All right. 30 seconds more.
Same.
All right, good. Hold on. Okay, so, man. So this is the real question that we're starting off with today. It is possible to know if an ionic compound is dissolvable in water. Dissolvable and soluble in water are the same thing, by looking at the ions involved. So what are the ions involved? So I would like you to write this down. You don't have to write this bottom bit, but at least this top part. These have rules. There are rules that you need to learn. And when you learn those rules, I should be able to give you any ionic compound and you should be able to go, oh, that's soluble, or no, that's not soluble. That's the goal of this whole poem. Now, the problem with these rules, and I've said this before, is that there's not really a good pattern. And it's actually really hard to teach students about solubility because it's like, okay, you guys have to pretty much learn like almost like an alphabet, you know? So what that means is we need to find out what can we learn about these kinds of things and what do we need to pay attention to. The other problem here is that it's subjective. What that means is by subjective is what that means by a subjective is it means that it's hard to tell whether or not something has dissolved or not. Some people might say, hey, that's dissolved because it's completely transparent, whereas some people might say, oh, it's not completely dissolved because you can still see the little bit left over. You say, yeah, but nah, but yeah. So it's hard to tell. So that's just another problem as well, but that's more of a scientific problem. So you just got to keep that in mind. Down the bottom here, glass, oil, and plastic are insoluble in water, okay? But they're not ionic, so we're not going to study them. So when we talk about ionic compounds, we're talking about a positive ion bound to a negative ion. They're the only ones we're going to look at. Glass, oil, and plastic are not ionic, so we're not going to look at them as say, oh, are these going to dissolve? We're only going to focus on like salts essentially, and yeah, different types of salts, and whether or not a salt is soluble in water or not, and most salts are.
Yo, can you explain ionic? I never understand that shit.
Okay, ionic means oopsies. So an ionic compound is when you have a if you remember what we did was during periodic table we talked about how there are different ways that a molecule can exist, and one of those is you have two what are called them atoms, and they're bound, and the reason they're bound is because we'll call them, one of them is positively charged and one of them is negatively charged. And the reason we say they are bonded is because this positively charged one is attracted to the negative charge, and the negative charge is attracted to the positive charge, and they make up and they stay together because they're attracted to each other. The A plus, that is an ion. Okay, so when we talk about ionic charge, when we talk about ions, that's what we're referring to. So A plus is an ion. A and B minus is also an ion. So ionic bonding is when you take two ions and you jam them together because they want to be together because they've got opposite charge. Most of the double displacement are, if I go backwards for a sec, these are ionic bonds. We've got a potassium is bonded to a nitrate. This is an ion, and this is an ion, and this is an ion, and this is an ion. And what happens is you just swap partners. You take this positive ion and you swap it with this positive ion, and they're pretty much the same thing. You take this negative ion and you swap it with this negative ion because they're pretty much the same thing. So that's what ionic charges mean, but they're the ones that we're going to be looking at today. We're not going to be looking at glass and stuff because they're not ionic bonding. Right, can I jump forward?
Yep.
Yep. Okay. So if you need me to stop or if I'm going too quickly, please let me know. You can message me privately, chat if you want. Say, sir, I don't want everyone else to know, but can you just slow down a bit? That's fine. Yeah. So, okay. Okay, so first one we're going to talk about here is alkali metals. Now, alkali metals are probably the ones that we're probably really familiar with. And there are essentially about 4 or 5 rules here. The first rule is this: alkali metals are always soluble. Doesn't matter what they're bonded to, they're always soluble, which means they always dissolve. So if you had, let me just do this, where is it? And I'm always going to give you guys, for these next couple of slides, 2 or 3 examples so that you can get familiar with it. Na2S, that's soluble. Why is it soluble? Because it's got sodium, and sodium is always soluble. K2O, guess what? That's soluble. Why is it soluble? Because it's got potassium, and potassium is always soluble. Doesn't matter what this thing at the end is, potassium is always soluble. Lithium carbonate, that's soluble. It's got lithium, and whenever you have lithium, it's going to be soluble. Technically, hydrogens would count in this situation too, but we don't really refer to hydrogens because technically when hydrogen bonds to these things, it's no longer an ionic compound, even though it sort of is, but we're just going to ignore it. We're just going to stick with the alkali metals. So lithium carbonate, soluble. Lithium sulfide, soluble. Potassium hydroxide, soluble. Potassium nitrate, soluble. You know, whatever, as long as it's got one of these N, K, or L, I at the front, it's going to be soluble. Is that first rule clear?
Yeah.
Wait, what? Can you explain that again? I got lost off track.
Okay, you see these 3, Li, Na, and K.
Yeah.
As long as, if it has that at the front, it's going to be soluble. That's it.
Oh.
No matter what.
That's it?
No matter what.
Oh, so like, if it has any of those 3, yeah, in front of anything, yeah, that means it's going to be soluble, right?
Yeah.
Okay, so
now, it's going to get a little bit more complicated as we go. So that's why I'm trying to stick to the simplest rules first. So this is the simplest rule. because there's no ifs or buts or whens. It's just if you've got Li, Na, or K, guess what? It's soluble. All right. Do you guys? I'm going to leave this up for a little bit longer, but then I'm going to take it down. I'm going to leave it up for probably another 30 seconds, but then I'm going to jump on to the next slide.
I'm done.
Good. 5 more seconds anyway. All right. Now, let's quickly talk about one of the classic examples here. Seawater is an example of dissolved NaCl. There is a bunch of dissolved sodium chloride. There's a bunch of dissolved salts in the sea. Now, that's not the only salt in the sea. There's also a bunch of KCl. And I actually think there's also a bunch of potassium iodide, Ki, in the water as well. So you can have like a lot of different types of salts in salt water, in seawater. But yeah, that's one of the straightaway ways that we know that it's going to dissolve. It's got Na in it. Na dissolves everywhere. It doesn't matter what it is. NaCl is going to dissolve. So yeah, whenever you think of NaCl, think of the water. So that was Na, K, and Li. Let's now move on to the next one, which is a couple more of the, which is the last two easy ones. So we're going to talk about ammonium and nitrates are also always soluble. They're always soluble. No matter what, they will dissolve.
What's that? What's that? I don't know how you pronounce it, but like, the first one. What is that?
Ammonium.
Yeah, what's that?
Yeah. So, pardon me. Let's give people a chance to write some stuff down before I start. But we'll talk about ammonium is a really weird. It's a really weird player in this game because it's actually a molecule, NH4 plus, but it is another positive ion. Okay, it's another cation. Now, a cation is a positive ion that is always soluble. And what do I mean by positive ion? Sorry for jumping back. All of these are positive ions. Na plus, K plus, Li plus. They're all positive. They all go at the start. NH4 is another positive, so it always goes at the start. So whenever you see NH4, it's going to be soluble. So here's NH4I, guess what? Soluble. NH4Cl, guess what? Soluble. NH4SO4, that's also soluble. We need to have 2 copies of the NH4 because SO4 is -2. Now, you guys should remember how to balance ionic compounds from semester 1. So you shouldn't need me to tell you that you need 2 of these to bond to one of those, but I'm going to be nice to you and give it to you anyway because that's not what I'm testing you guys on this term. But yeah, hopefully some of this should hopefully be ringing some bells. You should be like, oh yeah, I remember. You need to have balance out the charges. You need to have, if you've got 1 plus, you have to have 1 minus. If you've got 2 minuses, you have to have 2 1 pluses. That's how this works. Okay, writing this down, and then I'm going to give you guys like 30 seconds, maybe a little bit less. I'm going to give you guys about 15 seconds, and then I'm going to go through nitrates. Okay, 30 seconds, but yeah.
I'm done. If you're moving on to nitrates, yeah, I'm done from the other one.
So I'm
Yeah.
just cool. Let's go.
Go
So
on.
nitrates, NO3 minus is an anion. Now that's the opposite of a cation. It is a negative ion, and this is always soluble as well. So that means whenever you see NO3 at the end of a molecule, you know that molecule can dissolve. So if you see NH4 at the start or NO3 at the end, you know those are definitely soluble. So here we've got magnesium nitrate. Magnesium's a +2. So because you've got NO3 -1, you need 2 of those to balance out this +2. Aluminium is a +3, so you need 3 of these -1s to balance it out. Both of these, magnesium nitrate, aluminium nitrate, are soluble. Calcium nitrate, titanium nitrate, copper nitrate, iron nitrate, whatever you've got, lithium nitrate is going to be soluble. As long as it's got nitrate at the end, NO3 at the end, it's going to be soluble. It's going to dissolve in water. It's going to be fine. Down the bottom here is actually a mixture of both the left and the right. This is ammonium nitrate. It's perfect for fertilizer because it's got so much N in it. It's got NH4 and it's got NO3. It's got a lot of nitrogen in it. And sometimes that's what you really need, that plants need to grow, is a lot of nitrogen. And you know that ammonium nitrate is going to be really soluble. It's going to dissolve super easily because not only is ammonia always soluble, but nitrate is also always soluble. So those are the first 2 rules. Okay, first rule, sodium, potassium, lithium at the start, always soluble. Ammonium at the start, always soluble. Nitrate at the end, always soluble. Doesn't matter what the other thing is. Doesn't matter if it's a magnesium or a sulfate or an oxygen, it's going to be soluble. But now it gets messy. Okay. Now we need to start to really, now it's going to be, oh, it is soluble, but, and here is where it gets a bit of an iffy part. And this is the part that I often forget. And it's also the annoying part, is this is the part where different books say different things. I'm sort of trying to tell you guys all of the common examples, but I may get it a little bit wrong. And I essentially just want to give you guys enough information for you guys to get a feel for it. So the first one that we're going to talk about is the halogens. Now halogens, we're going to look at chlorine, bromine, and iodine. Now if you guys are pretty with it, you guys might be thinking, well, what about fluorine? Fluorine doesn't usually get mentioned by books, so I thought I'm not going to risk it and give you guys wrong information, so I'm not going to talk about fluorine. But I would 99%, I'd probably bet a good 80% odds that fluorine would apply to this situation as well. But we're just going to look at chlorine, bromine, and iodine. Chlorine, bromine, and iodine, these are all minuses, so they're all anions. These are always soluble except, or unless, there is an exception to what makes these guys soluble. Just like sodium, potassium, and lithium, these guys are always soluble unless they're bonded to silver, lead, or mercury. Ag, Pb, or Hg. These guys mean, if it's bonded to these guys, it means it's not soluble. So let's have a look down this list here. Sodium iodide. Well, iodide is always soluble unless it's bonded to Ag, Pb, or Hg. None of those are Na, so therefore tick, it's soluble. Cl is soluble unless it's bonded to Ag, Pb. Oh, it is bonded to Hg, Ag, therefore it's insoluble. So chlorine is soluble unless it's bonded to silver. It's bonded to silver, therefore it's insoluble. Lead bromide, same problem. You've got lead, That's one of the banned substances, so it's insoluble. Calcium chloride. Well, is calcium one of the banned substances? No. So therefore, it's soluble. I don't know how you want to check these. You might want to see, once you see ICLBr, check the other one. If it's a banned substance, so Ag, PB, or Hg, it's insoluble. But if it's not banned, if it's Ca, if it's magnesium, if it's, potassium bromide, if it's, let's go with beryllium chloride, it's going to be soluble. It's only if you hit AgPb or Hg. That's when you need to worry. So what I'm going to do is I'm going to leave this up for another 30 seconds, but then while you guys are copying this down, are there any questions about this one?
About what? About the whole slide?
Yeah.
Oh, no, not really. Wait, is it just those three?
Yeah.
Okay.
I will go into a bit more detail about how that works and how they decide, but yeah, at the moment, just understand it's just Ag, PB, and Hg. Now, what would make this easy, and it would be so quick to learn and teach you guys, is if these were the same exceptions every single time. But unfortunately, they're not. These exceptions change for different anions. And we're going to talk about some of the other anions now. But it's the same problem. So what we're going to talk about now is sulfate. Now sulfate, SO4 2-, this is another anion. It is negative, so it's an anion, it's a negative charge. And sulfate is also soluble. It's almost always soluble unless it's bonded to Ag, same, PB, same, Ba, which is different, and Ca, which is different. So if it's bonded to any of these four things, sulfate is not soluble. So you just got to be careful. You got to be careful around these metals. All right. So usually the trick will be it's like, oh, if you see one of these metals, if you see like a PB, if you see lead, you should definitely have your warning lights on and be like, ooh, this is lead. Something weird's going on here. And if you see Ag, if you see silver, you should have your warning lights on. Ooh, something's not right here. My other warning lights are whenever I see an element that ends in A, so Ba or Ca, I'm like, ooh, wait a second. Is that going to be soluble? Because that's when I start to be careful. So copper sulfate, that's what actually this blue crystal here is. Such a brilliant blue color. I kind of love it. Copper sulfate is soluble. Let's check why. It's sulfate. Sulfate is usually soluble. Is copper Cu on the banned list? No, it's not. So therefore, tick, it is soluble. Let's look at lead sulfate. Ooh, lead. Lead is probably on the banned list. Is it on the banned list? Yes, it's on the banned list. So therefore, this is insoluble. So if you add lead sulfate to water, it'll sink to the bottom and won't dissolve. What about mercury sulfate? Well, ooh, mercury. That's usually on the banned list. Let's check. But it's not. So therefore, mercury sulfate is soluble. This one at the bottom is meant to be tricky. Notice how mercury sulfate is soluble, but mercury chloride would be insoluble. You got to be careful there. Even though mercury is not on this list, it is on the other list. Also, calcium sulfate is insoluble, but calcium chloride is soluble. So you've got to be careful about some of these that appear on one list but don't appear on the other list. But these ones are pretty much the only ones that don't appear on both lists. I'll give you guys a second longer to copy this down, and then I'm going to change the slide, unless you guys want me to change it early, and I can do that. Also, ding ding, bell just went for end of first period. All right, so any questions about sulfate before I move on?
Nope.
No.
Uh,
Keep it going.
We've got a couple more, but before we do that, let's go back over it really quickly. So, sodium, lithium, potassium, always soluble, no matter what. NH4, NO3, always soluble, no matter what. NH4 is the front, NO3 is the first anion, the first negative one, but it's the only one that's soluble no matter what. Halogens, pretty much soluble, but sometimes there are exceptions. The exceptions are silver, lead, and mercury, AgPbHg. Sulfate, also almost always soluble, but there are more exceptions: silver, lead, barium, and calcium, AgPb, BaCa. So how do we wrap this up? We talk about the insoluble ones. Carbonates, pretty much always insoluble. Phosphates, PO4 3 minus, pretty much always insoluble. Sulfide, S minus 2, pretty much always insoluble. And OH minus, pretty much always insoluble, unless these anions are always insoluble, unless bonded to lithium, sodium, potassium, and ammonium. This is the first thing that we learned. We learned that these guys are always, no matter what, these guys are always soluble. But these guys are always insoluble unless you use this trick. So let's talk about different ones. Calcium carbonate, CaCO3. Well, CO3, that means it's insoluble. Ca, that's not an exception, so it's still going to be insoluble. I find this one a lot easier to do because I go CO3, insoluble. Oh, is that a sodium? Is that an Na or a K or a lithium? No, it's not. So no, it's definitely going to be insoluble. Good thing too, because that's what shells are made of, is calcium carbonate. It's also what our bones are made of. So I'm actually pretty thankful that they don't dissolve in water. I'm glad that, our bones don't just dissolve into our bloodstream randomly, because that'd be really, really bad. Aluminium phosphate. Phosphate, is insoluble? Aluminium. Well, that is not one of the exceptions, so therefore that's going to be insoluble. Lead sulfide. Sulfide means and lead is not one of the exceptions, so it's going to be insoluble. Hydroxide, OH, oh, it's got an Na at the front. Na is an exception, so sodium hydroxide is soluble. And lithium carbonate, because it's got lithium at the front, is soluble. But usually, hydroxides, carbonates, sulfides, phosphates, and usually these four things are insoluble. If you had to guess, 9 times out of 10, they're going to be insoluble. So, and insoluble means they don't dissolve in water. I'm going to leave this up for a little bit longer, and then we're going to do an example. And then I'm going to leave you guys the rest of the period to work on some of these questions. Okay, so these are the rules. The next part would be, well, how do we, like, you've gone through 4 or 5 rules here. So how do you remember these? There are different ways to remember these rules. The common way is to create something, and this is what I would normally print off and give to you in class. But the common way is to create, before I even do that, the mercury area. No pencil here, don't copy this down. Some of these compounds are slightly soluble. You don't have to understand why, I'm just showing you. So PbCl2, right? I told you guys that Cl, if it's bonded to lead, it's insoluble. But PbCl2 is actually slightly soluble. Same as calcium hydroxide. It's hydroxide, it's only soluble if it's bonded to NaKli. But calcium hydroxide is slightly soluble. All of these are murky. And that's because, and that's when I said at the very, very start, hey, this stuff is subjective. It's like, oh, well, you know, calcium, you might say calcium hydroxide, that's not soluble. But it's like, yeah, but it sort of dissolves, a little bit of it dissolves. So does that mean it's soluble? And you're like, oh, maybe, maybe not. And then you might be like, oh, you can get all of it to dissolve if you heat the water up to like 100 degrees Celsius. It's like, well, I don't know if that counts. And that's where you end up with this, with some people saying, oh, this is soluble, and some people saying, no, this isn't soluble. Calcium hydroxide is actually the main thing that you use when you make tofu. That's why I've got a picture of tofu here. And so it is important to have something this be dissolvable in water, or else you wouldn't be able to get it to go onto tofu. So kind of, but it's sort of in that gray area. I guess the idea that I wanted to show you guys here is that these rules I'm teaching you guys, you guys can't see me at the moment, but I'm using inverted commas, are rules. They're not, you know, set in stone. If you've got a calcium, then you cannot be dissolved. It's sort of like, it's just general sort of understanding, okay? And I know that's really difficult to teach, especially to science students, because it's like saying, yeah, this isn't black and white. It's like, well, what about the test? Okay, well, in a test, if you write down calcium hydroxide is soluble in a test, I'm going to give you a cross because you haven't understood this rule here. But I'm saying in real life, it's not black and white. How do you memorize these sort of things? This is the one that comes from style. I liked this one. It was a quick and easy one, and it was easy to memorize. But you've got, look, all sodium compounds are soluble, or potassium compounds are soluble, or lithium compounds are soluble, or nitrate compounds are soluble. All sulfates are soluble except for this one, this one, this one, so on and so forth. They could have put these together into one, but they didn't. And then all carbonates are insoluble unless they're bonded to this one, these ones. The reason I don't like this is because they skipped out on ammonium, NH4+. So that's why I went through ammonium here with you guys, just so that you knew it. I also don't like how they skipped out on barium as part of the sulfate one. So if you look at barium, if you look at sulfate, it says AgCaPb, but it doesn't have barium because technically barium sulfate is a common non-soluble thing. But these solubility rules are great. If you want to like, this will be in style. So if you want to copy these down into your book as a sort of way to summarize those rules that we've just learned into one easy table, then that's fine. You can even, if you want, combine these three together and combine these three together. That's another thing you could do. But there are these rules everywhere. This is one that I tried to find one on the internet quickly, and so that's what I did. This is a quick one that I ripped off the internet. You can see here that sulfate is soluble unless it's bonded to silver, potassium, barium, and lead. But it's also got this one here. Remember, I told you that hey, or this it's going to be subjective. Every single one of these is going to be a little bit different. It says here that it says here, for example, this one's the same. I have no idea what that is, but I'm just trying to show you guys. And in the book, I should really show you the book. Actually, I'm going to show you the book really quickly. The book doesn't have a nice table. Oh no, I closed my book. Oh no, I didn't. It should be. The book doesn't have a nice table. The book does it like this. Soluble or not, this is how they do it. They do it as a list of instructions. So they say all these compounds, NH4, K+, will dissolve in water. Notice how, again, this is almost complete, except it doesn't have lithium. I'm like, oh my God, you're killing me here. These ones, all things are bonded to chlorine, bromine, except if they're bonded to these three, which is what I said. Sulfate, except for barium sulfate, lead sulfate, calcium sulfate, so just like what we did. And then I said some compounds are slightly soluble, and that's where that list I got from. And then they have some examples here. We're going to finish up with our own examples. So let's finish up with our own examples here. And then I've got one more little thing that we're going to do at the very, very end, and then that's going to be it. I want you to go down this list. I would like you to give this a try on your own first. Even if you don't copy all of these down, I want you to guess whether it's soluble, insoluble, or soluble or insoluble. So S or I. So soluble or insoluble. I'm going to be right back, but I'm going to grab what am I grabbing? A mouse, so I can actually copy these things down. But soluble or insoluble, write down your answers. Be right back. Okay, guesses, ladies and gents. First one, soluble or insoluble?
Insoluble?
Insoluble. Why do you think it's insoluble?
Because BA is bonded with sulfate, I think. I don't know.
You're right. It's not because of the BA. It's sulfate is almost always soluble, but BA is one of the exceptions. So therefore, it's insoluble. Who wants to tell me for NH for who wants to tell me for ammonium sulfide, soluble or insoluble?
Wait, what? You should repeat that.
Second one down, soluble or insoluble?
Uh, um, it's insoluble.
Why do you think it's insoluble?
I'm just making guesses, dude. I'm tired as hell.
Let's have a look here. Sulfide is an S. S is sulfides are always insoluble, but if it's
Yeah, I
bonded
said it.
to one of these, is the number at is the one at the front one of those?
I have no idea.
It is. This is soluble.
Oh shit.
The reason it's soluble is because, yeah, sure, sulfide is normally insoluble, but NH4 is here. It's one of the exceptions. Let's look at lithium nitride. Is this going to be soluble or insoluble?
That's definitely soluble.
You are correct. It is definitely soluble.
Yeah.
The second you see lithium, I don't even care what's coming afterwards. It's going to be soluble. Nitride hasn't popped up at all in this whole lesson because but it doesn't matter. It hasn't popped up because you just need to know that it's got lithium. What about manganese nitrate? Anyone in chat can post, by the way.
Soluble.
Soluble? Yep, this is soluble. Manganese nitrate is soluble. So because it's got nitrate, anything with a nitrate is going to be soluble, no matter what. What about iron hydroxide?
It's gotta be
Insoluble.
yeah.
Insoluble. Let's check. Well, hydroxide is always insoluble, right? Hydroxide is always insoluble unless it's bonded to one of these four. So then you go, is iron one of those four? No, it's not. So therefore it is definitely insoluble. Last one, zinc bromide.
That's soluble.
Did you say soluble or insoluble?
Soluble.
It is soluble. Bromine is always soluble unless it's bonded to one of these things, silver, lead, or mercury. And zinc is not silver, lead, or mercury. So that means it's soluble. So those are some quick tricks. And that's pretty much all you need to really be able to do a lot of this work, is just be able to compare it to those lessons. And that's why having a table like this will make your life a lot easier. You can just quickly look it up. You could just quickly go, oh, well, where's hydroxide? Hydroxide is here. We've got NaKli. Well, there's no iron here, so therefore it must be insoluble. But the trick that I always struggle with is to go, well, if there's no exceptions, then it has to be insoluble. Whereas in this one, if there's no exceptions, it has to be soluble. So just like we have to remember, if there is an exception, to change. If there is an exception, you want to change what this word says. So the last thing we're going to do, is going to be this one here. What happens if I react Na2CO3 with CaCl2? Will there be a precipitate reaction? How do you work this out? Well, what you do for a question like this to work out whether or not there's going to be precipitate is you write down the possible products. The possible products in this case, and I would like you to write this down, is going to be, well, we're going to take, I keep losing my mouse. If you wonder why I get random lines, because I can never find my mouse. we're going to swap the Na with the Ca. So that's going to give us at this front Na, but instead of bonding that Na to CO3, we're going to bond it to Cl. So we're going to have NaCl. And then we're going to take that Ca and we're going to bond it to the carbonate, CO3. We're going to swap the order. So Ca bonds with CO3. Now, with these kinds of things, it actually doesn't matter too much if you don't get the ions balanced quite correctly to figure out if it's soluble or not. But you should still work on getting them balanced correctly. So in this case, Na is +1, Ca is +2. So you need to have CaCO3. So then the quick thing is to just check to see, well, if they're soluble. Is NaCl soluble? Or is it insoluble?
Oh shit, you're asking something? It's soluble.
NaCl is soluble, but what about calcium carbonate?
That's gonna be soluble.
No.
Insoluble.
Carbonates are always insoluble. So if it's calcium carbonate, then it's probably going to be insoluble. There are exceptions to when carbonate is soluble, and that's when it's bonded to something like Na. So when it's bonded to sodium, because it's an alkali metal, it's going to when it's bonded to sodium, it's going to dissolve. So what you actually end up with is when you mix those two things, sodium carbonate and calcium chloride, you will get an insoluble thing. So you will get something sink to the bottom. So that means that this is a precipitation reaction. And it's a quick way you can check. That's the end of the lesson.